I recently made a video where we restored an IBM PS2 model 55SX. In that video we discovered that the electrolyte from leaky caps in both drives had started to eat away at the PCB. So today we're going to restore, and if needed repair, these two Model 70s. Hopefully it's not too late to save those drives. The PS2 to the left here is an 8570-821. According to the specs at Ardent, this machine has a 386DX25, 64K of level 2 cache, 2 megs of RAM, and 120 meg ESDI hard drive. It has onboard VGA graphics and can do 640x480 at 16 colors. I think this machine has what's called a planar type 3 or 4. I'm not sure, but I guess we'll find out. The PS2 to the right is an 8570-121. According to the specs, it should have a 386DX20, 2 megs of RAM, 120 meg ESDI hard drive, and no cache. And if I'm not mistaken, this machine has the Type 1 board. This machine is also clearly missing the cover. That's because we had to snatch it for another project a couple of years ago. I'll see if I can find it and we'll put it back on. I had also left a note on this machine here that says black screen. Okay, let's start with this one, since the lid is off already. Unfortunately, the previous owner seems to have snatched some of the parts, because the diskette drive and the hard drive is missing. We also have 3 empty slots back here. The RAM stick, however, is taped down inside here, so I have probably used it to test another machine. Apparently I left the battery in, so let's start by pulling that battery off. It's a Panasonic battery with IBM part numbers. Not sure about the date code here, but I think it's week 1 of 1990. So quite possibly the original battery. There is some liquid damage on the motherboard here. So the legs of this chip here are heavily corroded. So maybe that's our black screen. The Model 50 that we have restored earlier on this channel had the fan back here. And when we checked with a thermal camera, a couple of the components inside the power supply got extremely hot. But with this slightly later Model 70, they have blocked off the vent holes at the back and installed the fan directly to the power supply here. So this power supply is probably running slightly cooler. We also have a date code here, week 30 of 1990. So that's a matching date for that battery. It has an international power supply made by a company called Procond. Never heard of those guys. Just like the Model 50, this case is almost toolless. It actually includes the tool to take it apart, sitting down here underneath the speaker. So if we pull that thing off, it's designed for these tabs. I think we need to pull that riser card off before we move on. It has 2 slots for diskette drives at the front, but it also has a slot for a hard drive at the back. So with all those tabs disconnected, I think we can pull this drive bay off. Like so. The screws holding the power supply in are both missing. Same thing with this screw here, so we should be able to just pull this power supply off. Yes, someone has definitely been messing around with this machine. Perhaps trying to fix that black screen. We've got more liquid damage here. 5 or 6 chips here have some corrosion on the legs. It doesn't look too good, but it looks repairable. Either I'm wrong about that chip, or this machine has been upgraded, because this is a 386DX25. If it has been upgraded, we also need to check for bent pins, since this machine has a black screen. Date codes on the BIOS chips, and many of these chips here, are from 1988. The date code at the chassis here is from 1988 too. So which one is it? 1988 or 1990? Maybe this IBM was put together with parts from different machines. The motherboard is held in place with just 3 screws. I can't quite tell if the I/O shield is stuck to the motherboard or to the chassis. So let's remove these screws too, before we pull that motherboard out. I had a Model 50 back in the day, but these machines should be quite a bit faster. Motherboard is stuck in something. Probably in that I/O shield. Yes, it was stuck to the I/O shield. Okay. Underneath the motherboard we seem to have broken off alignment pin. We also have some scratch marks over here and over here. So I think someone pulled this motherboard out using a screwdriver. This corner here is broken off. So someone in a hurry has pulled this motherboard. These plastic tabs often break, but on this chassis here there's only one small piece missing on this tab here. So this chassis is in a really good shape. To remove the speaker we need to push on this tab here and then pull the speaker off. Okay, the screws are missing in the power supply too. So someone has been inside here too. I don't mind, but he should have put all the screws back in. It seems to be held in place with these tabs here. And the usual disclaimer applies, of course. Please don't poke around inside power supplies. They may contain high voltages, even with the cord unplugged. That being said, this power supply has probably not been powered on in decades. Okay, we have some dust. This power supply definitely needs a proper wash. That is disgusting. I can't see any Rifa or Vima branded caps. In fact, I can't see any safety caps at all. That is odd. I can't see any empty pads for it either, so I don't think it has been removed previously. However, we do have this module here that is marked 2 times 0.7 micro x2, so here's our safety cap. It's probably inside this module here. Don't know if it's just a plastic cover. We need to pull this board out to check. What a sneaky power supply. Trying to hide away those safety caps. I have seen something similar, but I think that module was way smaller. I think this is the last screw. The power switch seems to be held in place with plastic tabs here. Unfortunately it's not red. I don't know why they switched to white switches. Those red switches look much cooler. PS2s should have red switches. I haven't seen any brittle plastics here yet, but I'm being very careful just in case. I skipped ahead here. That was not quick and easy, but now I finally think it's coming off. Yes, and the plastic clips didn't break. Great. The fan has a connector. Very dusty and disgusting connector. It's a 12 volt Mitsubishi fan. Now let's see how the main connector comes off. Apparently with some plastic pieces that I need to find on the floor now. Okay, here they are. The IC connector is hooked up to the PCB with the connector 2. That is great. These can be a pain sometimes when the cables are soldered to the PCB. It slides out from these plastic parts here, one on each side. Okay, nothing odd at the back. No bulging electrolytic caps. I don't remember why I wrote black screen. It could have been something from the ad. Or maybe I have tested this machine. Fuses are okay. Let's pull that module off before we wash the board. Because I want to know if it can be taken apart and checked inside. This pin here is hooked up to something really large, because it takes forever for that solder to melt. Okay, module is coming off. Oh no, it's definitely not designed to be taken apart. Crap. Well, I guess I'll do some googling. Okay, I'll do all the cleaning off camera. So let's move on to this machine here. So supposedly this is one of the high-end machines. Speaking of cleaning, by the way, this case probably looks okay on camera, but it's actually really disgusting. So there's going to be a lot of cleaning off camera. At the back we're missing one of the thumb screws, and we have at least one card. Interesting. I thought this drive was missing, but the eject button is actually recessed quite far inside the machine here. So something is wrong here, but at least there's a drive inside. So let's pull that lid off. Oh, we've got 2 cards. Oh, this is great. This is off to a good start. We have what looks like a memory expansion card, and I'm pretty sure this is an 8514A. Let's undo those screws at the back and pull those cards out. Yep, definitely a memory expansion card with 2 SIMs and 2 empty slots. I don't remember the exact numbers, but I think the motherboard can take 4 or 6 or maybe 8 megs. If you want to go beyond that, you need one of these cards. That is great. I didn't know I had one of these. Okay, this machine is pretty clean inside. Oh crap, I forgot to remove the battery in this machine too. Let's pull that out. I can't read that date code, but it has IBM part numbers. Okay, let's pull this card out. These are really cool. Well, without even checking, I know this is an 8514A, and it has the expansion card with all that extra memory. This project is off to a good start. Sure enough, it still has the drive, but why was that eject button recessed? We'll check later. These are 2 less 2. By lifting the tab, you can pull these drives out. And sure enough, caps are leaking. So this drive needs to be saved. Then we also have this drive here. I don't know what it is. Let's find out. What is this thing here? It's branded Mountain. There's a model number here that doesn't tell me anything. Made in the US. I think it says 40 meg here. Well, it's obviously some kind of tape drive. And pulling that drive out, it also reveals that this is a completely different motherboard. We've got a CPU and a Mathco on a separate board here. And these guys here look like cache chips. Interesting, let's explore some more. We've got a date here, week 50, 1988. I'll use that nifty tool to undo all these clips. Unlike the Model 50, these are not stuck. They actually undo quite easily. And there's one more hidden underneath here. Oh, that one was actually loose. So maybe it's broken. This machine also has some of those really nasty sticky seals that are sometimes found in PS2s. We're gonna see a lot more of these when it's time to restore the Model 80. This drive cage is really badly stuck in this corner here. So let's remove the power supply first to get better access to that corner. Okay, when I took this screw out here, the thread insert here came right off. So let's see if we can take it off anyways. Same brand on the power supply in this machine. And the date code, week 51 of 1988. And some more of that black sticky stuff. I think it's foam that has decomposed. Let's pull that power supply out. Okay. And here's that insert that is supposed to stay in the chassis. I guess we could glue it back in. Inside here we have a loose seal. Now let's see if we can get that corner unstuck. That is pretty bad. I'm gonna have to use some force here. Well, I'm not sure, but I think the cage has been incorrectly installed. And it's jammed behind the I/O shield. So let's remove the I/O shield first. And try again. No, that didn't solve the problem. Ah, I see. It was this tab here that was jammed. Yeah, these tabs don't age well. So now this one here is jammed. Now it came off. Oh, we're in luck. So they actually didn't break. And check out this contraption here. So the CPU and the FPU are mounted on this board. And it also has this large ceramic here. And this is a 38725. This chip here is the 386-25. A strange contraption. Oh, and these cache chips here, they are MT brand. So I wonder if they are still working. And here comes the motherboard. Nothing wrong on this side of the board. All seems okay. Date codes on these BIOS chips here are from 1990, and at least some of these chips here. So that's probably when this IBM was made. Now I got that nasty black goo stuck to my bench. This stuff is really disgusting. I better clean that off before we move on. Otherwise I'm gonna have to clean my workbench. Even with IPA, it takes quite a lot of scrubbing. What a nasty goo. Not even acetone worked on this stuff. But at least I got it to a point where it's not sticky anymore. So if you know of a good method to remove this stuff, then please share. Apparently those were not missing screws on the other power supply. These are in fact rivets. So let's get those off and have a look inside. Okay, this power supply looks almost identical, and this power supply is incredibly clean inside. There's hardly any dust on the fan, and I can't see even a speck of dust inside here. So this power supply doesn't need any cleaning, well, aside from that goo on the outside. So I'm gonna leave that weird module in, as if Google can help us out here. Oh no, there's a lot more of that nasty goo on the inside. Oh man. Well, I'll do some cleaning off camera and I'll see you on the other side. Okay, everything is cleaned up. Let's move on to the fun part. I'm going to assume that something is wrong with this machine, since the rivets were taken out of the power supply. So we have 4 potential issues here. This board has a 40 MHz crystal, so that is definitely not the original chip. We also have some liquid damage in this area here, and on these 2 chips here. I also noticed that one of the pins is bent on the VGA connector here. So someone has forced something into this VGA connector. That could definitely explain the black screen. We also have a potential power issue, since someone has been inside the power supply. But let's start with the liquid damage here. So these vias here, and a couple of these, are corroded. And these pins here don't look too happy, but they're not moving. So this is probably not causing any issues with the board yet. But let's fix it before it gets any worse. I found small pieces of that nasty black foam while I was cleaning the motherboard. So I wonder if this was caused by such a piece. Let's see if we can fix this with good flux and some solder. Well, that didn't work. Let's add more flux and more solder. Well, it's starting to look better, but not good enough. Let's see how we're doing underneath that flux. Yes, it's definitely improving. So let's do some more flux and more fresh solder. Yeah, now those legs start to look as they should. By the magic of flux. Okay, so this row of pins is now good. I'll do the rest off camera and clean this mess up. Okay, here's the final result. The corrosion is gone, and these vias here are now tinned, and all the legs look nice and shiny. Moving on to this area here. So somehow liquid found its way to U155 here, and messed up these pins quite badly. The damage reaches all the way up here and all the way down to this chip here. So I'm gonna have to clean up this entire area too. But let's try something new. I'm going to use the abrasive rubber tip for my Dremel tool, but as suggested by Tony359, I'm not going to attach it to the Dremel. I'm just going to use it by hand. No need to bring out a large tool for a small damage like this. Yes, I think that works. Let me clean that dust off. Yes, it definitely works. So this is a great method if you're fixing up a very small part of a PCB. Okay, that method worked really well. So all the corrosion is gone and all the vias, with minimal scratches to the solder mask. But we still need to tin them. And of course take care of the corrosion on all the legs. So let's do one chip on camera. I'll add some flux, some fresh solder, and I'll let the flux do its magic. This method often creates bridges between the pins, so you need to check afterwards and remove them. More flux, more fresh solder, and wick. And I'm just going to clean the vias. And there you have it. This side of the chip is now fixed. Nice and clean and tinned. I'll do the rest off camera. Okay, that took some patience, especially cleaning up the flux part. Gets very messy very quickly, but now it's done. I'll do a proper wash again after the video, that way I can upload on time. Next I want to check the CPU. I normally wouldn't do this, but since this machine was marked black screen, this CPU has clearly been replaced. We better check. Those pins are nice and straight. And a 25 MHz CPU should work just fine on a 20 MHz board. Okay, I think it's time to start testing things. Let's start with a high-end board here. So this board came without RAM sticks, but with a RAM expansion card. I have reassembled the matching power supply. So let's turn the power on. Fingers crossed. Okay, the fan spins up in the power supply, but we are getting nothing on the display. Okay, so is this board broken too? I don't know if these boards will post without RAM. So let's install some RAM. Let's try with the RAM stick that was taped down inside the other machine. It doesn't have any IBM part numbers, so I hope it's a compatible RAM stick. I guess we're about to find out. White line flashed by on the display. No, absolutely nothing. Crap. Okay, so the first thing I want to check is that 386, because it doesn't say DX. It just says 38625. If I'm not mistaken, there is a number underneath that we can Google and find out if this is a proper DX chip. Okay, pins look fine. Now let's check that number. Well, that's rather unusual. I couldn't find any information online about this chip. Never had this happen before. So I can't say if this is a proper DX chip or not. So for the next test, we're gonna borrow the chip from the other machine that clearly says DX25 on top of it. Okay, let's do a test with this chip installed. No difference whatsoever. Okay, so these guys here are not marked slot 1, 2, 3 and 4. Instead they are labeled J17, 18, 19 and 20. So I just assumed that this is SIM1, and of course it's not. I checked with Ardent, and apparently this is slot 1. Okay, let's try again. Oh no, it doesn't post. Crap. Let's try with one of the SIMs from that expansion card. Fingers crossed. No, we're getting nothing. Okay, I did some reading. Apparently this board is very picky with RAM. It only takes 2 meg modules in each socket. And these are 4 meg modules. Turns out I have quite an assortment of 4 meg modules. But I don't have a single spare 2 meg SIM. So I'm gonna have to look through all my machines and see if I can find one. Let's try with some RAM from the P70. No, that didn't work either. Well, I've never had a working Model 70, but I would expect an error if this was the wrong RAM stick. So this is probably not a RAM issue. Let's test the other board, and we're gonna test it with a freshly tested 386 DX20. That is what this board should have had originally. Okay, let's power up. No, we're getting nothing. But let's do a test with the speaker attached and see if we get any beeps. No, we're getting no beeps. Well, this board has a bent pin on the VGA connector. So let's make a test with the 8514A card. I can't believe this. So I've got two Model 70s and both are black screen. What are the odds? Well, I couldn't find any information about what RAM this machine takes. So let's try the stick from the P70. No, as expected, no change. Well, my postcard won't fit these weird and wonderful MCA slots, but I've got one of these. This is a postcard for the parallel port, so let's give this a try. Okay, a bit difficult to get on camera, because the supplied USB cable is really weird and very short, so this is the best I can do. When connected to power, it gives FF, and one of the LEDs is lit up. Let's give this a try and see what happens. Oh, nothing much. So either there's a compatibility issue, or this board is doing absolutely nothing. We've got 4 zeros. Well, that wasn't very helpful. I've never used one of these cards before, so perhaps I'm doing something wrong here. Let's try the other board. This is even worse because I have the IO shield installed. Now it starts off by 7F. When I connect it to power, let's give this a try. Well, it's hard to read the display, but I think it says 5500. What a weird postcard. Okay, that leads us back to the basics. The fan spins up, even without a load. So let's check some voltages. So pin 2 is ground, and pin 1 should be -12. And we're getting -12.2. So that is good. And pin 3 should give us +12 volts. 11.8, that's good enough. And pin 15 is our 5-volt rail, and it's fine too. Okay, so the power supply checks okay. Okay, let's see if the power stays on when hooked up to the board. Okay, so we've got ground coming up through a via here. Pin 1, -12, and pin 3, +12 volts, and pin 15, 5 volts. So it's not a short on the motherboard. So probably not a shorted tantalum. Let's see if we're getting any power to the CPU socket. So we've got VSS down here and VCC up in the corner here. And we're getting perfect 5 volts. Okay, well now we've got power to the CPU. Next, let's check the reset line. It goes high. And it stays high. Okay, so here's our problem. This board is stuck in reset. That would explain why we didn't get any post codes. The BIOS doesn't execute any code until the CPU has come out of reset. Okay, we've got a lead. Let's check the other pins before we move on. So now we're hooked up to the ready pin. It goes high and it stays high. So let's check CPU clock next. Okay, we are getting something. Definitely a clock. And the board is running at 40 MHz. So the clock is fine on the board. So why is it stuck in reset? Well, never had any issues with the reset line before. But I think checking for a short should be a good start. No, it's not shorted to the VCC. Well, I couldn't find any schematics for this board. The only schematics I could find was for the Model 80. Those schematics weren't of much help, but that's actually a good thing, because on the Model 80 the reset pin is hooked up to a custom IBM chip, whereas on this board it's hooked up to this D-type flip-flop. It's just a regular 74F74. I used my multimeter and poked around all over the board, and this is the only chip leg I could find that is connected to the reset line. So if this is our faulty chip, this board is still fixable. Let's hope for the best. Let's start with some Flux. Let's be nice to this board, use chip quick. So if you're new to this stuff here, it's just like regular solder, but it stays molten for much longer. So if we heat both sides up, we can just gently remove the chip. We're not using excessive heat on that crusty old board. It's very important to get that stuff off before we solder this chip. Because if you solder the chip with still some chip quick on the legs, the solder joint won't be strong enough. I'll just quickly clean that up. I don't have an adapter board for a SOP 14, but this 16-pin board will have to do. So let's solder all these legs to the adapter board. Cut some pin headers to size. I'll use a breadboard to get those pins soldered nice and straight. I'll just quickly solder all these legs. We can then test this chip. I've had some mixed results testing chips in a TL866. But let's give it one more chance. Let's go to Logic IC Tests 7474 and run the test. Oh crap, it tested good. Well, I'm not going to trust it entirely. So let's swap that chip with a chip from another machine. Let's remove that massive chip quick blob. I'll add some flux and clean up what's left of that chip quick. This is a pretty common part, so it should be easy to find. But I don't want to postpone this video for a week, so let's borrow this chip from the Model 50. Okay, that should be reasonably straight. So let's just drag solder all the pins. I'll clean up the flux and we can move on to tests. I find it easier to remove most of the flux with a dry Q-tip before I start cleaning with IPA. Otherwise it's just going to make a bigger mess. I can't quite remember, but I think the F series is slightly faster than the LS series. Okay, fingers crossed. Oh no. It still doesn't post. Something else is wrong with this board. Well, let's keep looking. So here is our suspect pin. Let's turn the power supply on. Yeah, sure enough, it just goes high. And it stays high. Well, without schematics, this repair is starting to get really tricky. But I think for the circuitry to work, this chip needs a clock. So let's see if we can find it. Yeah, there it is. Well, I wasn't expecting 10 megahertz, but that's what we have, at least on that pin. Okay, we've got 20 megahertz on this pin here, so that's the main crystal divided by 2. And VCC is good too. Crap. Everything looks alright here. Well, I've had quite a few older IBMs with shorted tantalums, but I have yet to see an IBM PS2 with bad tantalums. But it is of course a question of when, and not if. These guys are going to go bad. So let's check a few of these. These outer legs here are both connected to ground. So I'll start checking these guys and see what we get. 150 ohms, that is perfectly normal. I'll just start at the top here and check every one of them. Nothing. 150 ohms. 150. 150. I guess I'll skip ahead here, unless I get something interesting. No, all the tantalums are fine. They are reading either infinity or 150 ohms. So they are still good. My guess is for about 5 more years. I wish I knew how the circuitry is working. Something else must be involved in this circuitry here, but I have no clues to what that might be. Okay, I went through the tedious task of checking another pin on this chip here. And pin 1 is going all the way down here to this binary counter here. I looked through all my stuff, but unfortunately I don't have one of these, so we can't swap it, but I guess we could test it with a TL866. I also checked pin 2 here. That pin is going to this pin here, and this is another 74F74. So let's swap this chip first, and then test the other chip in the TL866. Okay, let's test that second flip-flop. 74F74. All vector testing normal. Okay, so that chip is good too. Let's not trust that TL866. I swapped that flip-flop. Let's test again. No, that's not our bad part, unfortunately. Unfortunately, that binary counter isn't in the list of the TL866 to test. And I don't have a spare chip, so we can't test it today, unfortunately. So this is a TI part. It only says LS590 on the chip, but I presume it's a 74LS590. By the way, remember that seal we found underneath the PCB? This thing here is actually conductive. So I wonder if this caused our problem. Perhaps this thing here shorted something on the PCB. Okay, I found one more connection. So pin 2 here is going all the way down here and hooked up to this chip here. This is a TI AS08. That's just a bunch of AND gates. And it's also connected to this pin here. That is our previous suspect that I don't have a replacement for. But this chip here is easy. So let's test it. Okay, 7408 to the test. All vector testing normal. So another good chip. This is like looking for a needle in a haystack. Let's make sure. I have installed a known good 7408 on the motherboard. Nope, no difference. Time for an experiment. I have connected a clip to the reset pin of this chip here. That's what we have on the scope right now. But I have also added a resistor to this clip. If we turn the machine on, the reset goes high. And just like before, it stays high. But what if we take a clip hooked up to ground, and immediately after I start the machine, I'm going to pull the reset line low by connecting ground to this resistor here. Let's give this a try. No, it still stays high, but it went down to 3 volts from roughly 5 volts. So maybe that resistor is too much. Let's try again, but this time I'll bypass the resistor. Okay, so now it went low, but nothing happened, so maybe I was too slow. Let's try that again. No, still no postcodes, no beeps. So there is more to this than just pulling that reset line low. Or perhaps we have more than one fault on this board. I think I need to do some reading and thinking. I was just about to test the other board when I realized that we haven't checked if the power supply is sending the power good signal to the motherboard. Until that signal is sent to the motherboard, it's actually supposed to be stuck high. I found the pin on the power supply, and I also checked, and it goes to this via here. So let's check it. Oh crap, I can't access that via because of the fan when the power supply is hooked up. Well, that's an interesting way to test the board. Well, this will have to do. So let's measure the power good pin and turn the machine on. Well, that's a weird reading. That is not a good signal. Let me check my ground connection. Okay, let's measure the ground from here instead. So that pin is ground, and this is power good pin. No, we're getting nothing. So is this our issue? Let me double check all the pins. Yes, we measured it correctly. Pin 2 here is ground, and pin 50 is power good. I think we may have found our fault. So if we're getting nothing on pin 50, that board is never gonna go out of reset. Let's do the same test with the model 50. Yeah, we're getting 5 volts on the power good pin. So we have a bad power supply. All that tracing, probably for nothing. Okay, I have washed and reassembled the other power supply. Let's see if this power supply works better. Pin 2 to ground. Let's check pin 50. Oh no, we're getting nothing. So both of these power supplies are bad. What are the odds? I was about to check the voltages, but this power supply is completely dead. It's doing absolutely nothing. Okay, 2 machines and 2 identical bad power supplies. I guess I should try to fix them, but I'm not sure if that's an interesting video to watch. But I'm definitely going to try to fix them. Well, the power supply in the Model 50 has the same pin out, but it doesn't have a fan. So we can't use it, but it's good enough to make a test and see if this motherboard works. Fingers crossed. No, it doesn't. What are the odds? 2 bad power supplies and 1 bad motherboard. Let's also try with the graphics card, since that VGA connector is damaged. No, it's dead as a doornail. No codes on the postcard and nothing on the screen. I also have the speaker attached, but we're not getting any beeps. That motherboard is dead. Well, I guess we should test the other motherboard too. Power on. Oh, we're getting postcodes. It went to 11. Oh, it's posting. We've got a 211 error. That, if I'm not mistaken, is a RAM error. Let's install some RAM. Let's try with the 2 SIMs that were installed in that expansion card. Still getting a 225. Let's borrow some RAM from the P70. No, still 225. Crap. Let's try that RAM stick that was taped down inside one of the machines. Nope. Well, I seriously doubt that this is going to work. But this is how the machine came. So why not give it a try? Nope. Let's try with a 2 meg module from the 55SX. No, 225. Well, this video was a bit of a fail, I'm afraid. I thought we would mess around with SCSI and graphics cards, then play some ad-lib games. If you're watching this in the future, there will be a link on the screen shortly where we finish this project. That is going to take a few weeks because I need to find some RAM that is compatible with this board before I continue. If you're watching this fresh, hit the bell icon below and set it to all to get a notification when the next video is out. And now is a good time to watch the more successful video where we restore the 55SX, if you haven't watched it yet. I will end this video by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you want to help me make more videos like this, like and leave a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.